Hello everyone, once again I welcome you all to the course on VLSI design. In continue with the previous lecture, in this video I am going to pay attention to the advantages of positive skew. As we know from the previous lecture, a positive skew is a concept where the input data flow and the clock flow are in same direction, and this is the corresponding timing diagram for the positive clock skew. If one can remember exactly, then the points in the timing diagram 1, 2, 3 and 4 are the edges received by the flip-flops, namely R1 and R2. Here we are interested in the advantages of positive skew. So let's consider the scenario. Let's say a resistor R1 receives an input signal. What it will do, it will simply get the input, and it is given to the input of the combinational circuit, and the combinational logic will generate its output, and it is given to input of R2. Then R2 will get that input, and it is passed to the next circuits. This is what happening. Resistor R1 gets the original data input, say logic 0 at point 1, and it is passed. Then this data is passed to combinational circuit, and the combinational circuit will evaluate depending upon the logic circuit. Say the combinational logic circuit will generate a data 1, and this data 1 is taken by the register R2 at edge 4. So one has to note very clearly, initially the time available for the combinational logic is TCLK, but now because of the clock skew, this delta, the time available for the combinational logic is increased by an amount of delta, right? This one, TCLK plus delta. So when we look at the equation, this equation, the timing equation, this tells us clearly the advantages of positive skew. Let's forget about this delta. Let's forget about this delta in this equation. Then the total time period is equal to the three things: TCQ, T logic and T setup time. Let's consider this T is equal to 100 nanosecond. The addition of these three time will gives 100 nanoseconds. For example, let's say this delta is 10 nanosecond. So from this equation, from the second equation, one can subtract this delta from the total time. So the combination of TCQ, T logic and T setup time is equal to 100 nanosecond, and the contribution by this delta equal to 10 nanosecond. So therefore 100 nanosecond minus 10 nanosecond, so approximately is equal to 90 nanosecond. Now this is the time period given to combinational logic circuit. So what is the advantages of the reduced time period for this TCLK? So one can clearly understand the rate at which the sequential circuit is clocked is greatly reduced. So before, without any clock skew, every 100 nanosecond the registers are clocked, which means the registers are clocked means the registers R1 and R2 receives the positive edge signals every 100 nanoseconds. But now, because of this clock skew, the rate at which the registers are clocked is reduced by 10 nanoseconds, which is equal to 90 nanoseconds. So which means the the rate at which the registers are clocked is greatly reduced by 10 nanoseconds. So by this way we can increase the speed of a circuit. Okay, so one can understand this in a better way, like when let's consider initially without any clock skew the time period is equal to 100 nanosecond, but after clock skew it is 10 clock TCLK, the time TCLK is equal to 90 nanosecond. Okay, but if we add this 90 nanosecond plus a delta which is equal to 10 nanosecond, then we will get 100 nanosecond. So therefore obviously this 100 nanosecond is equal to this 100 nanoseconds, so there is no problem. The circuit operation does not affect in any way, since we when we decrease this time period by 10 nanosecond. Okay, so and this is the one of the major advantage of the positive clock skew. So this positive skew is a harmful effect when we increase the delta. So as we know, this is the parameter delta. The delta is a clock skew. When this delta is small, then there is no problem, it is an advantage. But this when this delta is large, then the circuit operation will collapse, and that concept is discussed we will discuss in next lecture.